This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gregory Caphammer. Today's guest is Eran Yahav. He's the CTO of Tabnine and a faculty member in the Computer Science Department at the Israel Institute of Technology. Eran, welcome to Software Engineering Radio.
Hey, great to be here. Thank you for having me.
Today, we're going to be talking about the Tabnine AI coding assistant. It uses large language models to help software engineers complete tasks like code explanation and test case generation. Eran, are you ready to dive into the episode?
I'm definitely ready, yeah.
All right. So one of the things I noticed on the Tabnine website is that it has 1 million monthly users. First of all, congratulations. That's really cool. What I want to do now is to talk a little bit about what those Tabnine users are doing. Can you give a few concrete examples of how software engineers use Tabnine?
Yeah, sure. So the Tabnine provides assistance across the entire SDLC. It helps you write code with code completions that are very advanced. It has a chat interface that allows you to create new code, review code, refactor code, translate between languages, generate tests, as you mentioned initially, document code, explain it. So it basically helps you do anything that you have to do as a software engineer. And the vision is really to provide agents that help you do anything and everything a software engineer does, just faster and with a higher quality.
So you mentioned that it helps software engineers both move more rapidly and also do things with better quality. What's the reason that Tabnine helps that to happen?
I guess there's so much boilerplate and so much boring work in code generation, in programming. We know that. And for years, people have been obviously copying snippets from past projects, from Stack Overflow, from the internet at large, just to get over these boring things and get over with it. And then you basically get whatever is out there. With the rise of LLMs and with the rise of assistants like Tabnine that can contextualize deeply on your context, on your organization's code, etc., you have the opportunity to generate these pieces of code much more efficiently and more, I guess, true to what they should be in your context, right? So part of the quality of the code that you're generating is being suitable for the environment in which you're operating. And I think this is one particular aspect that Tabnine excels with.
So later in our episode, we'll dive into the specifics of Tabnine's implementation and how software engineers can use it. Before we do that, at a high level, can you explain a little bit about how Tabnine actually automatically performs these tasks?
Yeah, sure. So at the bottom of the whole thing are obviously large language models, right? LLMs. And they are capable of doing amazing things these days. They're very powerful and they're becoming more powerful on a weekly basis almost. But from the LLM to an actual use as a software engineer, there is a whole that has to happen in the middle, right? Part of that is the context that I mentioned earlier. So Tabnine has what we call the enterprise context engine, which is something that basically knows how to draw relevant context from all code sources of information and non-code sources of information in the organization to make sure that, again, Tabnine operates like an onboarded employee of the organization and not as a foreign engineer in the org. So Tabnine knows everything about the org, and which informs the code that it generates, how it reviews code, etc., etc. The second thing that is there between the LLM and the agents is a component that provides trust. One of the major questions that we ask ourselves as engineers when we delegate a task to AI or even to a junior engineer is, how can we trust the results that we get back, right? And Tabnine really focuses on that with something that we call coaching, Tabnine coaching. And that allows Tabnine to make sure that the code being generated and code being pushed into your code base follow organizational specific rules of what does it mean to be high quality code, what does it mean to follow organizational best practices, etc. So again, we can and will talk about the technical detail of how these things are done later, but if you're trying to look like for 30,000 feet view here, it's more contextual, context, organizational context, trust, and agents that are built on top of that.
Okay, that was really helpful. We're going to dive in more to the issues about trusts and the specific LLMs that are used by Tabnine. Before we do that, I wanted to just get a high-level perspective of the various features. Maybe if I could read off a feature and then you could briefly describe it, we might be able to give the listeners a full-featured picture of some of the things that Tabnine provides. So you talked about this already. Let's revisit code generation. How does code generation work in Tabnine?
Yeah, so in the old days, as I call it, which old days meaning like 2 years ago, maybe that's like ancient history, like this is akin to Roman Empire in terms of AI for software engineering. Most of the users were really using code completions to generate the code, and it could be either code completion just from typing, the prefix and getting Tabnine to complete what you're typing, or typing a natural language comment and getting code generated off that. Progressively, I think, or increasingly, people are using more and more the chat interface to generate larger amounts of code, even code that crosses file boundaries, different places in the projects that have to be updated. So you can just describe what is that you're trying to do as a very high level prompt, and Tabnine will generate the code, do the whatever modifications required for you. And I think we're seeing more and more code being generated that way.
Thanks for that description of code generation. I'm operating under the assumption that Tabnine can also generate the documentation for the code. Is that correct?
Yeah, absolutely. Generating documentation, to me, when we started, sounded a bit off because, I've been taught that documentation should describe why things were done and not what or how they're doing it, right? But turns out that, first of all, it's better to have some documentation than none. And second, once you get Tabnine to generate some documentation, turns out that developers are actually completing the part that is, so the extra information that only the human knows, maybe. So it's different writing documentation from scratch versus, hey, Tabnine already generated the bulk of it. Let me just add a couple of sentences here that clarify for Eran of the future why this was done this way.
So it sounds like Tabnine can generate both documentation for the code it's generating, and it can also generate documentation for existing code in your code base.
Yeah, absolutely. Yeah.
Okay. Now, a moment ago, you seemed to hint at something which looked like a larger scale change. So how does Tabnine support things like large scale code changes or system refactoring?
Yeah, system refactoring, I think we're not quite there yet. I think large-scale changes across multiple files, edits that take into account existing microservices in the organization, and edits that refer to code that exists elsewhere in the org. These are all things that are enabled by the Tabnine context engine. And again, I think it's quite remarkable and surprising the kind of things that we can do right now by prompting Tabnine or assistants in general and getting them to make changes across, tens of files in the project, changes that are consistent and compile and run, right? So that's, I think, something that happened really in the past year or so, that progress. I expect that to keep improving so we can make changes across the entire org, maybe refactoring across the entire org.
Thanks for that response. I heard you say a moment ago that Tabnine operates in an agentic fashion. Can you explain what that is?
The agentic fashion for us varies for different levels of autonomy. At a high level, we mean something that has a higher degree of autonomy than just a human AI conversation of like a request response or chat question and answer, right? We mean something, for example, that can say, hey, Tabnine, generate all the tests required to reach a certain code coverage target. Or, hey, Tabnine, why don't you give me a test plan for something and then implement it, right? So things that are multi-stage and quite sophisticated and involve planning and you don't know upfront, for example, how many iterations it requires with the LLM and things like that. Again, we can get into like technical definitions of all those things later, but just to give the intuition, we're talking about things that have a higher degree of autonomy than just a conversation.
Okay, so if I'm working in a way that there's less autonomy, I might be, for example, writing code and Tabnine will complete it. Or I might ask Tabnine to generate a test or generate documentation. But as I give it more autonomy, it's taking on more of the tasks for me. Is that the right way to think about it?
Yeah, that's the right way to think about it. And in general, people talk about coding assistants versus agents versus AI engineer. And there's not much of a dichotomy there. It's actually a continuum, right? As we increase the level of autonomy in every task, and as we increase the percentage of tasks that can be completed by AI, we are getting closer and closer to the AI engineer. And I think the challenge is to do that in a way that continuously provides value to the developer and still maintains the trust in the delegation, right? It's all about delegation. The AI assistance or the AI engineer is a matter of delegation. So if you think about code completion, that was kind of a micro delegation, right? I typed something. I did not have to specify anything because the specification was implicit. The prefix and the context were the specification, right? And then Tabnine completes it. So that's a micro delegation. And the question of trust is also quite simple. It's very tight, human in the loop trust. You, Greg, look at the completion and say, oh yeah, these 3 lines look great. That's exactly what I would have written myself. Or, hey, let me think about it for a second. That's not what I would have written, but it looks correct. So let me take that. So that's kind of a micro delegation. And you can say that ambitious delegation is like, here's the definition of my project. Let me give you like 1 paragraph in English. Go ahead, develop the backend for me, the front end, everything, the CI, the integration, and come back when you're ready, right? So that's a higher degree of autonomy. But now trust is a little more challenging. Am I, or are you, Greg, going to sit down and review 30,000 lines of code generated by AI and make sure that they did what you wanted in the spec? Does your spec even cover all the kind of twists and turns of the possible implementation? And so that continuum, like going from the micro specification with the very tight human in the loop trust with kind of common sense judgment, all the way to high level spec and somehow establishing trust on that. I think that journey is interesting, and that's what we're doing.
I really like that concept of a micro delegation all the way up to a macro delegation. I think that's really helpful. Thanks for sharing that idea.
Yeah, I think really the future is every engineer is really a team lead, and that team lead is leading a team of AI engineers. They could be specialized in different domains, the AI engineers. They could have varying expertise, but I think every engineer would have to start thinking like an engineering manager in a sense, or at least like a team lead.
That's a great concept. Thanks for sharing that idea. One of the things I heard you mention a moment ago is the idea of review. Does Tabnine have features that would help me as an engineer to support automated code review for like a pull request on GitHub?
Yeah. Tabnine does what we call Tabnine coaching, which is organization-specific code review. So code review is really a challenging problem, right? You've been around as an expert on these areas of software engineering, and you know that code review is really challenging first and foremost on like, hey, what is even good code? And what are valuable comments? And what is just pure noise, right? I mean, do I want the AI to give comments about, hey, Greg, use more meaningful variable names? Maybe. Do I want comments, hey, your function has whatever cyclomatic complexity 15 and you should refactor it to be lower? Maybe. Not sure that these are like the super high value comments that I expect from AI, right? What I want AI to do is to give me comments that are thoughtful about the meaningful parts of the code. Hey, Greg, you are sending customer data without encryption here. That's actually valuable, right? That's a comment that I would like to get, not something that you may have division by zero. Again, division by zero is great and valuable, but there are many other ways, linters and, static analysis tools that I've worked on for many years that can give you that. But kind of the meaningful things of like, hey, you're handling the database connection in a way that may be leaking your credentials or something like that. These are the meaningful comments that I look for in code review. Sorry, but I went off a tangent. What I wanted to say initially is that what Tabnine lets you do is to define organization-specific rules of what does it mean to have quality code and like what do you consider quality code, right? So you can say, hey, in my project, we only serve our files from Google Cloud Storage. So if you're doing something else that serves files from another source, maybe that's correct technically, but it's not appropriate for my project. So you can define these rules. You can have Tabnine check them. You can have Tabnine learn them from past code reviews and code history. So it's really a very powerful module, and I'm really, really excited by it and excited by the key role that it plays moving forward to the AI engineer, because as I said, when moving to the AI engineer, when moving the delegation boundary to more code being generated by silicon, by AI, you need to somehow scale the question of trust or the problem of trust. How can we trust whatever it is that is being generated by these agents? So code review is central to that question.
Later, we'll talk about trust when it comes to the specific models that Tabnine has generated. But in the context of code review, I'm wondering, does Tabnine give us advice and do the code review in the IDE, like in PyCharm or in JetBrains? Or does it do it inside of GitHub? Where does the code review actually take place?
Yeah, so we have code review in the pull requests. You can do that in GitHub, GitLab, Bitbucket, wherever you work. So Tabnine's philosophy is to meet the developers wherever they work. And so we have that integration already with the main source code platforms, as I mentioned. And also, I think very soon it's going to be in the IDE as well. There's a CLI that you can invoke from your CI process and get the results in whatever format you'd like. Again, the idea is to have the same engine power all these integrations and have developers consume the results of the code review wherever they need it.
That sounds really interesting. So there's a Tabnine CLI that I can run in my terminal window. And then is it the case that I can also run it in GitHub Actions and then it comments on the pull request there?
Yeah, exactly right.
Okay, that sounds really awesome. Now, it's clearly the case that Tabnine is providing features in PyCharm or JetBrains or NeoVim, and I see you have a lot of different plugins. And now I've learned that you can also integrate with the CLI or into things like GitHub Actions. So how did you build all of these different interactions and integrations? Are they all separate tools? Are they all part of one Tabnine binary? How is this system actually built?
Oh, in terms of architecture, I think, first of all, IDE integration is really challenging. IDEs are plenty and they move pretty quickly in ways that are often not very backwards compatible. So the APIs are, again, you've seen these things. So really our design goal from the start was to keep the IDE integration really as a sort of a shell and have the engine outside the IDE. So Tabnine is architected as a central engine binary, which is written in Rust, by the way, that powers all of Tabnine's functionality. And the various IDE plugins are all talking to this single binary. And the binary does all the heavy lifting of all the interesting tasks.
So you mentioned architecture a moment ago. Let's dwell there. And then I want to talk more about why you picked Rust in order to build Tabnine. But first of all, from an architectural standpoint, I'm guessing that there are parts of Tabnine that run on the developer's workstation, and then maybe other parts that run in the cloud. Can you kind of explain how that works in Tabnine?
Yeah, so first of all, yes, there's obviously kind of the local integration with IDE plugins, awareness of the current project, what is going on in terms of existing code in your workspace, etc. Semantic analysis of the code base, all of that is happening locally on your machine. And Tabnine maintains some representation of your code base locally, so it can use that as part of the Tabnine context engine, right? So when you are doing something like generating new code, Tabnine is aware of your existing code. When you're doing code completion, Tabnine is aware of similar code that already exists in your code base. When you're asking to generate tests, Tabnine knows the existing test in your code base already. All those things are happening on the client machine. So there's some indexing and analysis, embedding, vector database, all the components that you'd imagine that exist in something like Tabnine are running on the client. And of course, there's a server side to the context engine that is, for example, creating the representation of all the code in the organization, creating a representation of non-code sources of information like Jira tickets, like Confluence pages, other sources of information. And that part sits on the server, and obviously the two communicate. In addition, there is the LLM inference itself, which runs server side because this requires GPUs for the most part, etc. Tabnine does have a way to run models locally, but we've been kind of increasingly moving away from that for the general LLMs. There are some models that may be running locally still, and we kind of play with moving models around based on trade-offs of, compute and latency and others. But generally, inference is happening mostly on the cloud these days, on server side.
Okay, that's really helpful. I noticed you talked about something called semantic analysis, and you mentioned that there's these various analyses that are running locally on the computer that the developer is using. Can you say a little bit about what semantic analysis is and why Tabnine needs to perform that task?
Yeah, sure. It's actually quite interesting and cute. I like it. As part of the context engine, when you are performing certain tasks, you need to know what are the available semantic entities that you can rely on. So the most trivial example is, let's say I'm in Python and I'm importing certain modules, right? Tabnine needs to know what does it mean to import a module and where that other module exists. In Java is maybe even a stronger example. You are importing things from libraries. Tabnine needs to know what is the signature of functions in the library, right? So it generates code that matches type signature as defined in the library. And for that, you need to understand the notion of import. You need to understand where is the library. You need to analyze the structure of the library. You need to actually have some representation of the signatures in the library. And you need to do that even when you don't have the source code available, which is typical for Java. So in Java, often you get some jar files that are the libraries, right? You don't have the source code for that. And you still need Tabnine to generate code that is correct to those signatures. And in order to do that, you need to do some sort of semantic analysis, understand the dependencies, et cetera, et cetera. It's not as trivial as it sounds.
So there's a Tabnine program implemented in Rust. It's running on my developer workstation. It's doing things like semantic analysis, and we'll talk more about how it's building up this program context. But just to make sure I understood you correctly, I think you're saying that Tabnine works across multiple programming languages. Is that true?
Yeah, it works across most programming languages or mainstream programming languages. It supports 80, but not all of them have the same level of sophistication in the semantic analysis, etc., etc. All major languages have pretty deep semantic analysis, but this varies by language. So definitely, I wouldn't say that we support, Java, TypeScript, Python, JavaScript in the same level that we support Lua, right? So I think you can imagine that the major languages have much better support in terms of the semantic analysis and other things. Yeah.
So this is a really interesting point, and I think it moves us into the next phase of our discussion, because what I'm understanding is that Tabnine needs to be able to represent program source code for Java and for Python and for JavaScript. So do you have some kind of internal representation in Tabnine that abstracts away from different languages?
So depends on the language. For some of them, we have something, but for the most part, I've worked quite a bit on static analysis and program representations that are, AST based and otherwise, and deeper than that. We try not to reinvent the wheel there, but use existing representations for most things. Maybe the most interesting thing there in terms of representation is sort of dependence graph, some dependence edges between important entities in the program. but not fine-grained representations beyond dependence graphs and ASTs. That's, I think, the important bits there. Obviously, we do have the embeddings of the code base with vector database in which we represent piece of code based on their embedding, and we can do nearest neighbor search in order to find relevant piece of code for particular queries, etc. So that obviously exists, but in terms of the semantic representation itself, you can think of those as additional edges over points in the vector database. Does that make sense?
Yeah, that makes a lot of sense. I'm catching what you're saying. And I do in a moment want to make sure that we define things like a dependence graph and an AST. But before we do that, if I could jump back 10 minutes, can you briefly comment again on why you picked Rust for the implementation of Tabnine?
Yeah, so it's a historical choice. I think it was not done by me. It was done by the original developer of Tabnine, which was 2019, I think. And the choice was always made to be cross-platform and cross-arc deployment to make those things easy. It's unfortunately quite hard to deploy to different OSs and different architecture in most languages without carrying over a huge runtime. And Rust solves for that problem. Originally, we were also doing a lot of very clever inference on the local machine. So that requires low-level work with CPU intrinsics and stuff like that. And then the choice is either really C++ or Rust. And, it's choose your poison, basically, right? I used to do a lot of C++, so I prefer Rust to C++ as well, but I don't want to get into that particular religious war here.
Yeah, what you're saying makes a lot of sense. Thanks for giving us those details. Now, also, I heard you say a little while ago that Tabnine's Rust-based program is creating an AST and a dependence graph. Can you explain both of those for our listeners?
Yeah, so again, let me recap a bit for the audience. So when we represent programs, we would like to know something that is a little more structured than just the program text. For that, we parse the programs based on the grammar of the programming language. We create a representation that is called an abstract syntax tree. The abstract syntax tree, you can think about that as a compact representation of a piece of code that abstracts away a lot of the details but keeps the essence. So you can have some tree-structured representation of a function, and inside the function, the different blocks of the function. Inside each block, you can say, hey, is here a conditional block, or is this a while loop, or whatever it is? And so it gives you a structured representation, a tree-based structured representation of a program in a way that can be unified also across different programming languages. So once you have the grammar of a programming language, you can use something like Treesitter or another parser to get an abstract syntax tree for the program. And that makes a lot of operations on programs much easier to perform, right, than just performing it on text. So that was the abstract syntax tree part. I think the other thing that we mentioned is dependence graphs. And again, not going too deep on what those means, but you can say something like, hey, I am calling a function foo, and that function foo is defined elsewhere. And so let me create some edge in my graph, in like a larger program graph, between the use of the function foo and the declaration of the function foo. And similarly, you can create dependencies between variables, between functions, between all sorts of entities in the code, maybe one class inheriting from another. You get the intuitive idea that entities are related in some way, and you like to capture those relationships so you can use them when, for example, creating context for an LLM-based operation.
Okay, thanks for that response. Now, very quickly, you mentioned something called a Treesitter parser. Can you briefly say what a Treesitter parser is and how that works?
Treesitter is just a name of a project from GitHub for parser generator, actually. It's a really, really nice project. They provide a bunch of parsers for most languages and a way to create a parser for your favorite language as well. And they have a lot of utilities that allow you to do that quickly and conveniently. It's a really, really nice project that I think the academic audience, if not already aware of, should really be made aware of and used in the research, whoever is doing PL research at least.
Thanks for that pointer. That's awesome. Now, what I want to do is leave the land of code and jump into the land of non-code. If I'm understanding correctly, Tabnine somehow knows how to incorporate design documents and issue tracker tickets. Can you explain more about how Tabnine manages those diverse sources of data?
Yeah, we're just in the beginning of that journey, but that journey is really important to us in the sense of, as I said, when you think about the levels of delegation and the future of the AI engineer, we see a lot of shifting left beyond the IDE into the higher or further left in the process into design documents, right? You will write the Jira ticket, hit a button, and get the implementation to a large degree, right? And so it's important to establish these connections and relationships early in the evolution of the AI engineer. And so this is what we've been doing. Right now, what Tabnine allows you to do, allows you to take a Jira ticket and say, operate on it as additional context for whatever it is that you're doing. So you can mention the Jira ticket and implement it directly in your IDE, which I often do, and it's quite cool. You can ask Tabnine to check whether your implementation matches what is mentioned in the Jira ticket. So you can say, hey, you know what? The Jira ticket said you should have such and such button. Actually, your implementation does not have that. But this is just the beginning of the evolution here. I think we are pushing forward on integrations that are going beyond that, like updating the ticket for you, expanding on the ticket for you, saying like, hey, the ticket is missing the following details based on what you already have in the organization, right? Or, hey, you said I should create a button that whatever updates employee details. There's a microservice called update employee details defined elsewhere in the org. Do you want me to use that, or do you want me to redevelop that part, right? So, and again, trying to bridge the semantic gap between what is defined at high level in a ticket and what already exists in the code base, which is, I think, one of the harder problems for engineers in general, right? Because it's hard for you to know. Let's say I'm a new engineer into the organization. I have no idea that, a microservice for getting employee details or updating employee detail already exists, right? And I may try to re-implement that. And if I use ChatGPT or something, it will give me a perfect implementation of a new service that does that. But I actually don't want to regenerate the service. I already have one that I should be using.
You brought up a good point. I think now you're highlighting one of the distinctions between ChatGPT or Anthropic's Claude, because Tabnine has access to this context and so must be able to make better decisions because it has more context. Is that the right way to think about it?
Yeah, I think, again, LLMs are commoditized and they are progressing in tremendous pace, but at the end, they are the computation engine and they need to be aware of what already exists. What is the context in which they're operating, right? So you can think about the LLM as kind of an ignorant genius. It knows how to do many, many, many things, but not in the relevant context in which I'm operating, right? And you can think about the best engineer in the organization as someone who really knows the nuts and bolts of how things operate, right? He knows or she knows, hey, that microservice depends on the other thing and that database is there. And you should actually never update the version of that module because something else depends on it. So they have this representation of the entire system in their head and they know how things interconnect and what should be changed together and what shouldn't be touched, etc. So that's the best engineer in your org. So you want really to bridge these two things, make the LLM as aware of the org as your best engineer. And this is how you get to 10x productivity of the AI engineer, right? To onboard the AI to your organization. This is really the task here. And this is what Tabnine is doing, kind of onboarding the AI to your organization in a way that the AI engineer operates like your best engineer. Ideally, Tabnine should always be the best employee of the month, right? Employee of the month award should go to Tabnine in organization.
Thank you for that response. That was helpful and informative. Now, in some of the projects I've worked on, I've had situations where the documentation drifted from the implementation. So how does Tabnine actually address the fact that some sources of context are really helpful and it's going to lead to it becoming employee of the month. But other sources are less helpful because they for example, no longer reference or represent the truth of the code base. Can you give more details about that?
Yeah, that's definitely a challenge. I don't want to overplay the abilities of the AI to kind of know what is really the best source of information here. And it is actually not that hard to mislead the AI. So let me just maybe give you an anecdote from customers, right? So initially, whenever you talk to customers, they say, hey, I have 30 million lines of code, and why don't I connect Tabnine to this 30 million lines of code to inform Tabnine? There's documentation there. There's a bunch of stuff as well, right? But they want to connect it to everything. And then they say, you know what, coming to think of it, 27 million lines of code from this code base, I actually think that no one should ever look at. That's like legacy, which is the counterexample for what we want to do. So let's disconnect all that and let's focus on the 3 million lines. They need not be the most recent ones, by the way. Initially, when I started, I thought like, hey, we just look at the recent stuff and that must be the right way to do things. It's sometimes correct, but sometimes they're just like some golden repository, something that is like, oh, here's like our best work, our masterpiece, and everything should contextualize on that, because that's the best way to do stuff, right? And so there's some nuance to that. And you still need some human guidance to connect Tabnine to the right sources and not mislead it. And in particular, there is a problem with huge legacy code bases that unless you're careful and give extra guidance through coaching, you may be trapped in the kind of Jupiter level gravity of legacy, in the sense that you will always keep generating code that is similar to the way you did things 20 years ago, right? You will be generating new legacy. So you don't want that. And this is also why we created the coaching module that allows you to explicitly say, you know what, Tabnine, that's the way I want you to do things, right? If somebody asks you to connect to a database, the way to do that is this new way and not the old way, right? So you can control what the AI does explicitly as the architect or as the dev manager or as the senior engineer.
So it sounds like Tabnine can, first of all, automatically assess the quality of some sources, but then it will also take hints from me as a software engineer in order to help me to be the human in the loop to point out what is good code or good docs. Am I thinking about it the right way?
Absolutely. So I think, again, if you think about it as onboarding the AI engineer to the organization, there are certain things you expect the AI to understand by itself. Hey, look at this code base, get the gist of it. You should just implicitly learn what's important. And Tabnine would do that. But certain things cannot, or maybe are too hard to be learned implicitly. And you want to control them explicitly as the human in charge, right? You want to say, hey, I don't care what you learned from this old crusty Java 8 code. We're in a different world now. And, here are the rules of the new game. I'm telling you as the architect, right? Here's the way to do stuff.
When I was reading the Tabnine documentation and checking out your blog posts, one of the words that I noticed you used frequently was provenance, and the other was attribution. How do provenance and attribution play into the tasks that Tabnine can automatically complete?
Yeah, I think those are important things when you are moving to LLMs that have been trained on anything and everything out there. So Tabnine really cares about what we call protection. And protection means protecting you against generating code that potentially violates IP, right? IP rights. And we have a model called Tabnine Protected, which has been trained only on permissively open source licensed code. So you can pick that if you're very protection conscious, if you're very risk averse in terms of IP, you can always pick Tabnine Protected. But as external models become more and more powerful and want to enable those for our customers and give them the freedom of choice without having to worry about protection, well, we provide provenance and attribution, or what we call also inference time protection, meaning that we have recitation checks and basically matching any code that is generated by Tabnine against all of the code out there in some abstraction, and letting you know, hey, Greg, you know what? This piece of code is really similar to the Linux kernel, which is licensed under GPL2, right? So hey, do you want to take that? Do you want your developers in the organization to not even see code of this flavor? Maybe you want to only suggest code that is MIT or Apache license. So Provenence attribution lets you find kind of the origins of the code being generated in case it is very similar to something else out there. And it does that at inference time, almost near real time, and you can configure the behavior, as I said, to even block those things from being presented to your developers. So Tabnine is, I did not mention that earlier, but Tabnine is like an enterprise first AI assistant. So we really care about privacy, about protection, about personalization to the enterprise. So all those things like privacy, protection, and personalization are the things that make Tabnine great for the enterprise.
Okay, that makes sense. I remember earlier in our conversation, you mentioned that trust was central to Tabnine. And now I'm understanding that inference time protection is one of the key ways to make sure there's trust between the software engineer and the Tabnine system.
Yeah, in some sense, protection is one facet of that. When I talk about trust, when I said trust earlier, I meant more on the functional side of things, more in the sense of like, hey, you ask me to generate whatever, something that connects to a database and gets all employee records. Can I trust that what I got is actually reading all employee records? Or maybe due to a pagination error, you only got the first 100 and you did not paginate through the tape, right? Like these subtle bugs. Or, hey, maybe you asked me to read all employee records and I did not know that they are across 3 different tables for whatever reasons, right? And I only got you one of them. Right, so these kind of functional things that I have to worry about when I delegate a task, this is what I talk when I say trust.
Thanks for that clarification. That was really helpful. In a moment, I want to chat about Tabnine and how it can help with things like automated test data generation. But before I do that, I thought it would be helpful if you could briefly comment on the different cloud-based LLMs that you can integrate in with Tabnine. Can you share more details with our listeners?
Yeah, absolutely. So Tabnine is always trying to bring the best models out there to our users. And as such, we offer all the latest, greatest models from Anthropic, OpenAI, Google, etc. So you can get Gemini, you can get Claude, Sonnet 3.5, you can get GPT-4, you can get all of these models. Again, the pace of innovation on these with new reasoning models and others is really, really fast. We are always going to bring the best out there to our customer, whatever matches their deployment restrictions, their preferred cloud provider, and maybe protection requirements. So our goal is really to work with the customer to see what are the requirements in terms of privacy and protection and preference to cloud provider and model abilities and provide that. As of today, we find in our internal benchmarks that Claude Sonnet is the best right now, but Google is having a very strong showing with the latest Gemini. And these things change constantly. So we give our customers the freedom to just switch between these models completely seamlessly. It used to be the case that different models had different performance across different tasks. So maybe one model is better for code review, another is better for test generation, and another is better for code generation. Right now, it looks like Claude is doing the best on all of them. But yeah, some open source models are also performing really well. Latest Llama 3.3, I know the latest QN family and others, yeah.
Actually, that's a really interesting point and something that I was going to discuss. So I can configure Tabnine when it's generating test cases to use one model, but then perhaps configure it to pick a different model if it's creating documentation or doing code review.
Yeah, right now we don't offer that control at the customer level. We decide for certain things, but you could, if we find that models diverge again in their abilities, we may open that again, right? Right now, it's just like if you bet on Claude Sonnet to do this, you're not going to be wrong, right? So no need for this fine-grained control on the customer side.
Okay, very interesting. Let's talk briefly about test cases. I noticed when using Tabnine that it can suggest test cases to me by looking at my code and then saying, hey, these 10 tests could be useful to you. So my question is, how does Tabnine decide how many test cases to suggest to me? And then how does it decide which test cases it thinks I will find most useful?
Yeah, that there's some simple agentic flow there that is trying to look at the existing test and see what is missing and then generate a test plan according to what is missing. So that's just, I think, V1 of the test agent. It kind of generates the test plan, allows you to refine it and then generate tests from the test plan. The next version is, as I mentioned earlier, something that is going to generate code coverage target completely automatically. So it's generating the tests, measuring the coverage, seeing what parts of the code are not covered, generating additional tests, etc., until you reach coverage. Of course, all of those things still require human supervision in the sense that you want these tests to actually be interesting and meaningful and not, cover code in trivial ways, and maybe also want them to be meaningful tests when going into the future, right? Only you, the human, kind of know where you want to go with this code base and what tests are kind of like forward looking, right? So you want still to provide some human guidance. But as I said, because the question of trust is so central, how can I trust the things that are being generated by the AI engineer? I think the code coverage agent and automatic test generation are also central tenets of what Tabnine is going to do in the future. So these agents are going to improve tremendously and also be tied to things that we see in code review and things that we see in runtime, etc.
Okay, so it sounds like coverage-guided test case generation is on the roadmap for Tabnine. Is that the right way to think about it?
It's working. It's not just on the roadmap. It's not released yet, but it's internally, this is something that we're close to deploying. Yeah.
So does Tabnine generate unit test cases or integration tests or regression tests or fuzz tests or all of those? How does it work?
No, right now, mostly unit tests, and the others, again, we will get there, not quite there yet. I think the regression is another interesting point to intervene, but I think this is still, there's some way to go there.
So in certain cases, I've either automatically generated a test or written one of my own, and then the test case fails. However, I ultimately realized it was a bug in my test case and not a bug in my function under test. So how does Tabnine distinguish between a test case that's failing because it's a buggy test versus a test case that's failing because it found a bug?
Yeah, obviously, without an additional specification somewhere, you would not know that, right? So the thing is, you need to enter that specification somewhere, and Tabnine will check against that. People are not that big outside academia about writing specs, really, right?
So when Tabnine is generating these test cases, can it also generate like the mock objects or the spies or the stubs that it needs?
Yeah, it does. It does. So if you need some mock objects, that's right, it would do that. Again, to a certain degree of sophistication, don't expect it to do, the level of mocking that you did in your super duper complicated project, right? But it will do the basic things. It will definitely get out of the way.
Okay, that makes a lot of sense. Now, I noticed that when I write test cases, sometimes my test cases aren't good because ultimately they prove to be flaky, or sometimes they're too tightly tied to the implementation and they're like a change detector test, which I would also consider low quality.
Yeah.
So does Tabnine have guardrails in place that help it to automatically generate test cases that are not going to be flaky or not going to be a change detector?
No, not yet. I think flakiness, I have not seen much, but definitely change detection, as you call it. I think that's definitely some bias in the AI, because that's like an overfitting to the existing implementation and generating the test that. I think that is happening. Not exactly sure how to generalize around that, but we'll see. These are problems we're working on.
So if there's a failing test case, can I give that test case to Tabnine and have it fix the program under test so that the test passes?
You can do that. It's not an automatic integration yet, but you can definitely point to it and say, mention the test and say, this is failing. Please change the code according to that. Yeah.
Okay, so we've covered a lot of very cool features of Tabnine. We talked about how it uses all of these different forms of context and how it can automatically generate test cases. Are there features of Tabnine that we haven't highlighted yet that you wanted to draw to the attention of our listeners?
Let me see, I have to review the things that I'm using all the time. So I think when you are working with a chat interface, for example, in Tabnine, One question is, how do you consume back the results that you get from chat? And I think we've worked really hard on kind of automatically applying these changes across files and things like that. That's going to be an area of further improvement in Tabnine. So in recent months, so I used to work mostly with code completion because I typically know what I'm doing and I'm like doing very point changes in my code, etc. So I'm probably doing what most would consider specialized work in the logic of the product and stuff that is fairly deep and deeply contextualized also. So I used to use mostly code completions, but in recent months, I moved to use mostly chat because since we introduced the apply all kind of magic, which is like, here's everything that was generated, just hit a button and all the code gets changed automatically. I started using that for almost everything that I do. And so that apply was the leap of abilities in Tabnine for me, at least as a user. And I think the further it improves, I find that I do less code completions, even for things I know exactly how to complete. Maybe even if it's a one-line change, I still do it in the chat interface and gonna have Tabnine change whatever needs to change in order to make it happen. So habitually, I would say, against my better judgment in a sense, I started using more the chat and less the code completion. And I imagine that, and I know actually, not just imagine, that a lot of the people who kind of adopt AI for real, like all in, are also transitioning to using more of the chat interface than completion. It's just, again, a question of habit. Where do you go first, right? And so I think the habits are changing in front of our eyes, right? So.
Yeah, that's a really thought-provoking insight, and it's something that I have noticed in myself and many of the other engineers with whom I regularly chat. So thanks for pointing out that change in developer practice and experience. What I would like to do now is to go back to what we might call the roots of Tabnine. You've actually been involved in publishing and presenting a number of research papers, and I think some of those research papers have actually planted the seeds for Tabnine. So there's two frameworks in particular that I wanted to briefly chat about. One is called Code to Sec, and the other is called Code to Vec. And it's SEQ and then VEC. And I think code stands for source code. Can you tell us what those other things are all about and how they influenced the creation of Tabnine?
Oh, these are beautiful works by my former student Eran and Meital Zilberstein and Shaked Brody, and I think one of them is also with other friends and contributors like Omer Levy from Google. These are really, wow, so much time has passed. These are circa 2018 and they're not even, or 2019, and they're not even the first work that we've done around code completion and these things. Like the first work that we've done around code completion, I think, is 2012, when we started seeing that you could do some ML-based code completion. And that is really what informed this entire line of work. So let me talk for a second about the specific things that you asked. Code to Vec was really a very nice work on how to represent a code for tasks like function name completion. Maybe you could use that also to predict names of variables and stuff like that. So it was very, very early and straightforward use of neural networks, I would say, for code-specific tasks. You can think of that also as like the first embedder for code, I would say, creating some neural representation or dense representation of code as vectors, as dense vectors. So I think that was 2019. That was really nice work. So that is Code to Vec. It's still very widely used because it's very simple. So it uses basically paths in the abstract syntax tree to represent a piece of code and then basically compute some embedding or some neural representation of those paths, of the combination of paths in the AST. So that was like the first work that we've done around that with really beautiful work by Uri Alon. And I think 1 year later, we did Code to Sec, which was generating a sequence from a piece of code. The idea there was to say, hey, let's generate just like captions for images. It was captions for pieces of code, right? So just generate a document or like a line of description for a piece of code. And those were tiny, tiny neural networks. This is, I think, neural networks in the size of like 150 million parameters, which is like in these days, this sounds like something I can probably run hundreds of those on my iPhone, right? So these are like early days of work on neural representations of code. And I think there has been a lot of follow-on work on that. We've done, again, a lot of work following that on adversarial examples for models of code and all sorts of additional practical work, like how to do edit completions by Shaked. I think Shaked Brody did very nice work on how to predict edits rather than to predict code completions. You want to predict how code is going to be edited. You made an edit in one place, you want to predict other edits in the same code, right? How code is being updated as a result of change. And there's a bunch of very nice academic work there. I think when we did all the academic work, the trade-offs are quite different than what you'd like to see in industry, right? So academic work is often very high accuracy, but maybe latency is too high to be used in practice. And maybe, you get 10% improvement in accuracy, but at 10x latency or 10x computational cost. And these things, again, for academic research, it makes perfect sense. And then maybe other people find a way to make this faster or better or cheaper. But the trade-off there is not something that matches the requirements in industry. So
thanks for sharing those details about the trade-offs. For listeners who are interested in exploring more, we'll link them to episodes of Software Engineering Radio that have also talked about generative AI and software engineering. And in the show notes, we'll also link to the websites for Tabnine and Code2Sec and Code2Vec. Thanks for giving us those details. I'm wondering, since you're both a CTO and a professor, and you've already begun to hint at this, can you share with us some details about how you transitioned a research prototype into production use?
Yeah, so I think my friends in Microsoft Research told me many, many years ago that when you transition from a research to product, you realize that the research part, or like the deep tech part, becomes at most 20% of the product at the end. So my experience has not been different. I think there's just so much that has to go into a product in terms of the user experience, in terms of how the product behaves, what are the kind of latency requirements, what are the cost requirements, what does it mean to do inference at scale. All those things are things that are not super interesting academically for the most part, but are really, really important in making things work for real. And I think I have tremendous appreciation for that practical work and for what does it take to make a real product work in the hands of real users, right? I think it's just a tremendous amount of work to do that. In terms of the research to kind of the academic research into practice lens, I would say that a lot of what people are doing these days in IEEE or FSC or a lot of the software engineering conferences in terms of the ML stuff is also being done in industry. And I think not necessarily in a worse way, just people don't really write about it, right? So I would say that people in academia, my advice and what I do myself also is academically is to think about how this would look 10 years from now, not 1 year from now, because the 1 year from now industry knows and the industry is already doing, even if you don't read about it in a research paper, right? And so it's not an easy task. So it's hard to imagine, 10 years from now how things would look, but trying to imagine and trying to imagine a completely different world of how people program is what I expect academic research to bring to the table. Doing prompt engineering for, code review. Sure, you can do some research about that, and it's interesting. It's not a solved problem in any sense, but I think industry is working on that, and industry will solve it in a way that is maybe not the most interesting, but definitely the most working and practical. I think that's the balance that I'd expect, like for academia to look further out. I think some people are definitely doing that as well.
Thanks. As we draw this episode of Software Engineering Radio to conclusion, I'm wondering, do you have a call for action to our listeners who are software engineers working in practice and may want to try to effectively apply generative AI tools like Tabnine?
Yeah, so it's the obvious advice, I guess, but just play with it, lean in, adopt these tools. They are not going away. This is how things are going to be. In some way, resistance is futile, and you should lean in, see what works for you. Not everything works the same way. Have realistic expectations. This is not some magical thing that will make all your work go away and will definitely won't replace you. So lean in, see what works for you and adopt it. I think realistically speaking, you can automate a lot of the kind of simple things, right? Which should give you more time to focus on the work that you want to do anyway, which is the creative work and, the deep algorithmic maybe or innovative work parts of your job. It is interesting to also see the evolution of how your code base should evolve to make AI's life easier. So if you think of how Tabnine works by contextualizing on the entire code base, and you know that it is doing some retrieval augmented generation that is based both on semantic and on semantic similarities and embeddings and stuff like that, you can think about, adding maybe a bit more documentation to your existing code base, maybe changing the names of functions and parameters to be slightly more meaningful, such that both future humans and future AIs can make better use of the code base. And I think these things are things to think about as you design a system for the future and as you refactor code for the future. Is not like, how do I make it easier for future humans, but also for the future AI systems that are going to want to leverage that. I think people who are going to build their code base this way are going to have better productivity multiplier from AI-based tools.
That's a really interesting insight and a great call to action for our listeners. Eran, thanks for taking time to chat with us on Software Engineering Radio. This has really been an awesome conversation.
Oh, thank you so much for having me. I enjoyed every minute.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.